Paxton Klein here to talk about out the front knives and how they work and what things like off track mean. Here's my favorite out the front knife. It's the Carbatech Enforcer. You push the button, back and forth the blade goes. Pretty cool. Kind of magic. How's it work? And then if you bring the button back, the blade gets like this. And what happens? It doesn't work anymore. This is considered off track. The knife can be reset by simply pulling it forward, and then it continues to work. Why does that work, and what do the insides look like that make this work? Here's one where I've loosened up the screws, and you can see the button fell off. But a note on the screws: it would be nice if the industry used industry standards screws instead of these kind of triangular shaped screws that were made popular by Microtech. I guess people do it because Microtech's the brand name knife, out the front knife to have, so everybody wants to copy it. So switch, it just sits in that little bump. This is what the knife looks like inside. This one's off track already. You can move the bar around. You see it doesn't really do anything. There's a spring on here, and the spring is under a little bit of tension to keep it from falling off. And you can see that there's a larger portion of this, or a larger bar on this side of the spring than this side. This portion of the bar here catches on the back of the blade. The shorter one catches on this button. Take the spring off to show a little more. All right. So when the blade is in its locked position like this, there's a little bit of tension from the spring, not very much, enough to keep it from rattling around, and it just pushes from back here, and this bar locks the blade in. Now, if we can move that bar, you can see that the blade comes forward. And if we were to put a lot of spring tension on this, because our thumb is pushing the bar forward, it moves the blade, and it moves it fairly rapidly. And maybe it moves it about this far. And at that point, the spring is no longer engaged. As the momentum of the blade carries it forward. So if it hits something like a piece of paper, it might put a little hole in it, but it's got no pressure. It's got no action behind it. There's no force behind it other than momentum. The blade comes forward, goes forward. Watch this bar here. It gets to the end of the blade. This one drops down. Now the blade's locked in the front. This spring here attaches to the bar. It provides a little bit of force to keep it pulled back, not much. So if we look at a blade like this, we can pull on it a little bit. Again, you can see that same movement here, but the spring keeps it backwards in the normal position. If we look at this bar, we can see right here, there's a machined spot. It's a ramp. So this blade is under some, so as you move the button back, it's difficult to see, but you can see that this blocking bar moves out of the way. That's due to this ramp. We'll simulate that here. As that blocking bar comes back, that ramp gets pushed up, unlocks the blade, it can come back. Now, but remember, we had the spring. And the spring was over this bar, and it's a little bit over it, about that much, right? Quarter of an inch or so. And as we move this bar back, right, the spring gets stretched. Eventually that bar unlocks, and the blade can begin to travel back. Again, all with momentum. And we saw about how far that was. We saw that when this was back. That's about as much as the spring is going to stretch. So 8/10 of an inch, 20 millimeters, not very much. In any case, when this unlocks, we'll see the blade move back, and again, it's not very far, right? It's about there, right? From this point, there's no more spring action on this blade. And it's going to use the momentum of the blade to come back. As it comes back, you can see it start to move this other blocking bar. It comes back, keeps going. Eventually that blocking bar moves into place. And the knife comes back. The other end of the spring, this catch, it fits on the back of the blade, and that's where it provides its action. And when the knife is when the switch is in the backwards position, you know, the blade has come back, it's had some momentum. There's a little bit of very light spring tension. You can see how much movement that is. Maybe 3 millimeters, 1/10 of what the spring is capable of compared to the other side. There's a little bit of pressure that holds it back. Otherwise, when you move the knife up and down, it would shake. Right? Without that spring tension, this would move back and forth. It's kind of a genius design. So that's the basics of how the OTF knife works. And again, from this side, there's pressure on it, camming action. As you move the switch forward, the spring gets elongated and stretches, and this cam here will move the blocking bar out of the way. As it moves it out of the way, we'll see that the blade moves forward. Again, to illustrate, this is in the rearwardmost position. The spring has a very slight amount of tension on it to keep the blade up against this locking lever. As we move the transfer lever, the switch lever forward, we see the ramp move the blocking bar, moves it. Now the blade comes forward, and it's going to come forward. And this is the forwardmost position on the switch. At this point, the end of the blade is moved past here. Spring provides no more power. That's about how much power the knife has when the spring has been pushed forward, and the rest is simple momentum. It takes it forward, and if it runs into a piece of paper, puts a little hole in it, and the blade stops. That's considered off track. Hope this helps you understand how an OTF knife works.